So one more thing um, that I want to talk about this week are type conversions in C++. Something you may have started to pick up on is that constructors are a kind of type converter. For example, if I have this really simple class and I declare a constructor that takes an integer as an argument, then a single integer, then I can actually write my initialization for this object A as saying, A equals 5. And the compiler figures out that that what I'm really asking for is for us to call this constructor that takes 5 as an argument and use it to construct object A. On the other hand, if I were to do the opposite, if I were to try to assign this object A to an integer X, the compiler has no idea what to do. Okay, so this constructor works as a type conversion in one direction, but it doesn't work in the other direction, going back to int. In fact, this idea of constructors that taking a single argument are interpreted as type converters is generally true. For however many constructors I have, the compiler will interpret those constructors that take a single argument as a type converter from the argument type to the class type. Which means if I extend my class A to have a constructor that takes an integer, that takes a double, or that takes a character string, then now the compiler automatically knows how to convert things of that type into an object of type A. Now this is pretty interesting because the compiler can automatically detect and apply these conversions. Let's say I have a function that takes an object of type A and I call it with a string. Well, what the compiler will do is it'll say, oh, you know what? I don't know about any function f that takes a character string as an argument, but I know that there's a function f that takes a class A. And then it'll go look inside class A, realize there's a constructor that'll convert from the string into that object, and it will apply that conversion and then be able to call function f. The same thing will happen here on this other call to f, where I pass in a double. It's going to go look at the type for class A and realize there's a constructor that accepts a double, and it will apply that constructor to create a new object of type A in order to call function f. And if you think back, we talked a little bit about how, and when we talked about function overloading, we talked about how the compiler would try to figure out which function to call based on matching up arguments and doing type conversions. So it turns out that part of that logic, the compiler tries to match types to the functions it has. And part of that process is using the constructors on the class to perform type conversions. Okay, but it's important to note type conversions, it only uses the constructors that take a single argument as type converters. Okay, and it will apply this automatically. Okay, but all this understanding still hasn't given us any headway here on this last case. When I write int x equals a, I'm asking it to convert object A back to X. It might seem like that'd be a trivial thing to do because A contains a field X. And maybe we could just grab that field and stick it in this variable. But we haven't instructed the compiler that that's acceptable. And so it doesn't know that it's acceptable and it won't do it. And this will be a syntax error. This last line here, x equals a, is a syntax error because the compiler doesn't know how to take an object A and turn it back into an integer. Okay, but the good news is we can teach it how to do that. And the way we do it is by writing a special type converter function, member function inside class A. And the general form of that conversion is that we specify the operator keyword, and then the type we're going to create to, so int, and then parentheses indicating it's a function. Const here just means that when I do the conversion, I won't modify the object I'm converting. And then we specify inside our implementation of the member function how to do the conversion. And in this case, since we just have a field x inside here, we're just going to return x as the way we convert back to integer. I'll just take a note here that, if I use double or character string to initialize this class, then what I do is I just store the double in the integer x, which throws away the real part and just leaves the integer part behind, right? It does a rounding operation basically. Or if I pass in a character string to this object, then I'm using a to y to convert the string into an integer. There's a little bit of error handling I should do here to make sure a to y succeeds, but I'm just, to keep my code simple, I'm not doing that. But as long as I pass in a string that represents a number, it's going to get converted into an integer. Okay, and then if I then were to ask this object to get converted to an int, then I would just take this field out of it and it would become an int. Okay, so now after I add in this conversion back to int, if I try to say x equals a, int x equals a, well, now it's going to work because the compiler sees that I have a special type converter as part of class A, and it knows this is a way that it can convert from my object to some other type, and it will apply that function and allow this code to work. You know, likewise, I could just cast a directly to int, and when I try to cast it to int, the compiler will go look for a suitable type converter in the class and then do the conversion for me. Okay, if I go back and I look at this code I had earlier where I called f and passed in the string 1, 2, 3, I could now take the return value of this function and say I implement f to just return a converted back to int, right? And this is going to use my new operator int type converter. Then if I pass in string 1, 2, 3, then this function f is going to convert this into object A. Then object A is going to get converted back into an integer. And so I'm just going to ultimately store 1, 2, 3 in x. Integer 1, 2, 3, 123. Likewise, if I pass in double 1.2, this is going to get type converted into object A, which will just have the value 1. And then when 1 gets converted back to an int, we'll just store a 1 back into y. Now here's a deeper look at how this is working for this one case. So if it's f and I'm calling it with the argument string 1, 2, 3, then the compiler doesn't find a version for f that takes a constant character pointer. It only finds a version of f that takes an object A. So it has to look for a type conversion. And it finds a constructor that'll do it, that can be converted. And so it kind of converts the code into this form. F with an argument of object A taking string 1, 2, 3. So this is going to produce a new object A that we pass into f. And then inside f, it converts that A into an integer. And that's ultimately what gets written into x as the number 123. Okay, if you want to write your own type conversion, it's pretty simple. Inside your class, you need to add a member function. You first have the keyword operator. Then you have the type name you're converting to, and then you have parentheses. And this would just be a declaration, but if you put braces on the end instead, you can just implement it right there in the class. The conversion function must be a class member function. It must not specify a return type. You'll notice there's no type over here specifying what it returns, because actually the return type is kind of specified here as the type name. And then the conversion function must take no arguments. Because you're just saying, I'm going to take my existing object and turn it into another type. You're not allowed to parameterize how that happens. These type converters play into picking the best function call to call as well. So right, with function overloading, when we call a function, the compiler has to decide which function of a given name to call, and it tries to match up the arguments. And type conversions play a big role when doing that. The compiler will try to pick a function that matches the name and arguments. And if there's an exact match, then it's simple. But if there's not an exact match, then it tries to do type conversions. And if you pass an object, if you don't pass an object to a function that expects an object, it'll try to do conversions on using constructors in order to make the object. Likewise, if you pass in an object that it doesn't expect, then it will try to use its built-in type converters to convert it to a type that it does want. And then the number of conversions it has to do to convert it to a form that's callable, you know, it takes that into account to decide the best match. And type conversions illustrate our ideas of encapsulation and abstraction, right? So type conversions are member functions that explain how objects can be converted to other types, and they're encapsulated in the object. And so that makes it easy to understand what that object can be converted, you know, from, and what it can be converted into. And it's an example of abstraction because the compiler automatically applies type converters implicitly, thereby hiding them from our view. And this makes the code potentially simpler and more intuitive. Okay, but I will just point out the caveat that sometimes having the compiler do a lot for you automatically can also be confusing. If you don't understand why code works, if there's some type conversion happening that allows it to work that you don't expect, that can also be frustrating. But the key reason we have these sort of features in the language is so that we can keep our code clean and not have to manually convert things all the time using a lot of extra syntax, and the compiler does it for us. Okay, so in summary, constructors that take a single argument serve as type converters from the argument type to the class type. Type conversion member functions allow objects to explicitly or implicitly convert to other types. And the compiler looks for these member functions to support finding the best match for function calls or for assignments. And so if you have such type converters, you can just rely on them to help perform conversions for you automatically.